Namaste dear children, how are you? I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Maths Chapter 4 Data Handling and Presentation. If you ask your classmate about their favorite colors, you will get a list of colors. This list is an example of data. So if you ask your classmates about their favorite colors, some will tell blue, some will tell green. Okay, so this list of colors is an example of data. Similarly, if you measure the weight of each student in your class, you would get a collection of measures of weight. Again, it is a data, measures of weight, the list of colors, all are datas. Any collection of facts, numbers, measures, observations, or other descriptions of things that convey information about those things is called a data. So, data is any collection of facts, numbers, measures, etc. that convey information about those things. We live in an age of information. We constantly see large amounts of data presented to us in new and interesting ways. In this chapter, we will explore some of the ways that data is presented. How we can use some of those ways to correctly display, interpret, and make inferences from such data. So, in this chapter, we will see different ways of representing data, then how we can use some of those ways to correctly display, interpret, and make inference from such data. Collecting and organizing data. Navya and Naresh are discussing their favorite games. So, Navya and Naresh, they are discussing about their favorite games. What Navya said? Cricket is my favorite game. Then, I think cricket is the most popular game in our class. Then what Naresh said? I play cricket sometimes, but hockey is the game I like the most. I am not sure how can we find the most popular game in our class. So, for Navya, cricket is her favorite game. For Naresh, hockey is his favorite game. Then, how can we find the most popular game in our class? Is it cricket or is it hockey or any other game? How to find that? To figure out the most popular game in their class, what should Navya and Naresh do? Can you help them? We will see. Naresh and Navya decided to go to each student in the class and ask what their favorite game is. Then they prepared a list. So, Naresh and Navya, they went to each student in the class and asked them what is their favorite game. Then they prepared a list. So, this is the list. See, Mehanur, his favorite game is Kabaddi. Then, like this, Jubimon, hockey. Then Simran, Kabaddi, Nand, Pittu. See the list here. She says happily, I have collected the data. I can figure out the most popular game now. So I have collected data. I have made a list. So I can figure out the most popular game from this list. A few other children are looking at the list and wondering, we can't yet see the most popular game. How can we get it from the list? So, how can we get the most popular game from this list? The other children asked. Figure it out. What would you do to find the most popular game among Naresh and Navya's classmates? So, we have to find the most popular game. We have given a list containing students and their favorite games. To find the most popular game, we should create a table with two columns, one for the game name and one for the number of students who choose each game. So first you create a table with two columns. One column for the game name and the other column for the number of students who choose each game. For each game, count how many students selected it and record that number in the table. So for each game, you count the number of students who had selected that particular game. See, for example, Kabaddi. See the list. 6 students, they selected Kabaddi as their favorite games. Similarly, you can find other games also. How many students like hockey, how many students like cricket, likewise. The game with the highest count will be the most popular game. So, the game with the highest count will be the most popular game. See, we have created the table with one column for game and the other column for number of students selected that particular game. See, Kabaddi. How many students selected Kabaddi as their favorite game? 6. Then hockey, 8. Then Pittu, 5. Cricket, 6. Badminton, 2. Football, 4. So, which will be the most popular game? What is the most popular game in that class? See, here see 8. 8 is the largest number here. So, hockey is their favorite game. Hockey is the most popular game in their class. Try to find out the most popular game among your classmates. That you can do. You can make a list of students and their favorite games, and then you can create a table with 2 columns, one for the game name and the other for the number of students who liked that game. Okay. Then the game with the maximum count will be the most popular game in that class. Then Patty wants to respond to the question given below. Put a tick for the questions where she needs to carry out data collection and put a cross for the questions where she doesn't need to collect data. So we have given some questions. What is the most popular TV show among her classmates? So she wants to collect data. Then, when did India get independence? No need to collect data here. Then, how much water is getting wasted in her locality? She could collect data. What is the capital of India? No need to collect data. Sri Nilesh is a teacher. He decided to bring sweets to the class to celebrate the new year. So, he is a teacher. He decided to bring some sweets to the class to celebrate New Year. The sweets shop nearby has jalebi, gulab jamun, then gujia, barfi and rasgulla. So, some sweets are there in the nearby shop. Jalebi, gulab jamun, then gujia, then barfi and rasgulla. He wanted to know the choices of the children. He wrote the names of the sweets on the board and asked each child to tell him their preference. He put a tally mark. This is a tally mark. See this standing line. This tally mark for each student. And when the count reached 5, he put a line through the previous 4 and marked like this. So, he put a tally mark, that is a standing line for each student. And when the count reached 5, 1, 2, 3, 4, 5, he put a line through the previous 4 like this. Okay. So, jalebi, how many students like jalebi? See, this is 5 plus 1, 6 students. Then how many students preferred gulab jamun? See, 5 plus 4, 9. Then, how many students like gujia? 5 plus 5 plus 3, 13. Then, how many students like barfi? Only 3. Then, how many students like rasgulla? 5 plus 2, 7 students. Complete the table to help Sri Nilesh to purchase the correct number of sweets. See, we have the table here. How many students choose jalebi? How many students? 6 students. Barfi was chosen by how many students? Only 3 students. How many students choose Gujia? 13 students. Rasagula was chosen by how many students? 7 students. How many students choose Gulab Jamun? 9 students. Sri Nilesh requested one of the staff members to bring the sweets as given in the table. The above table helped him to purchase the correct number of seeds. He could purchase the correct number of seeds. Is the above table sufficient to distribute each type of sweet to the correct student? Explain. If it is not sufficient, what is the alternative? This table is not sufficient. Why? Sri Nilesh should have also written student's name against each sweet item. Only then he could have given the right sweet to the right child. So to organize the data, we can write the name of each sweet in one column and using tally signs, note the number of students who prefer that sweet. The numbers 6, 9, etc. are the frequencies of the sweet preferences for jalebi, gulab jamun respectively. So, these numbers, they are called frequencies. Susri Sandhya asked her students about the sizes of shoes they wear. She noted the data on the board. So, she noted the shoe sizes on the board like this. She then arranged the shoe sizes of the students in ascending order. Then she wrote the shoe sizes in the ascending order like this. Okay, then figure it out. Help her to figure out the following. The largest shoe size in the class is, which is the largest size? It is 7. Then the smallest shoe size in the class is, see the first one, it is 3. There are dash students who wear shoe size 5. You count the number of students whose size is 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 students. There are dash students who wear shoe sizes larger than 4. So, how many students wore shoe sizes 5, 6, 7? How many students? See, 5, size 5, 10 students. Then, size 6, 4 students. Size 7, 1 student. So, how many students wore shoe sizes larger than 4? 10 plus 4 plus 1, that is 15. How did arranging the data in ascending order help to answer these questions? Arranging the data in ascending order helps to identify the smallest and largest sizes quickly. We can quickly identify which is the smallest size and which is the largest size. We can also count the number of occurrences of each item. Are there other ways to arrange the data? Yes, we can arrange the data in the descending order. Try the names of a few trees you see around you. When you observe a tree on the way from your home to school or while walking from one place to another place, record the data and fill in the following table. So write the name of a few trees and also write how many trees of that type you found. See, we have a table here. In the first column, you can write trees, and in the second column, you can write the number of trees. See, we have peepal tree, neem tree, mango tree, tamarind tree. See, number of peepal trees 2, number of neem trees 11, number of mango trees 10, number of tamarind tree 10. Which tree was found in the greatest number? Neem. How many trees? 11 trees. Which tree was found in the smallest number? Peepal tree. How many trees? Only 2. Were there any 2 trees found in the same numbers? Yes. Which are the trees? Mango tree and tamarind tree. Pictographs. Pictographs are one visual and suggestive way to represent data without writing any numbers. So, pictographs can be used to represent data without writing any numbers. Look at this picture. You may be familiar with it from previous classes. Modes of traveling, number of students. Then one symbol represents one student. So, how many students are using private car? 4. Because one symbol represents one student. So, 4 symbols represent 4 students. The number of students using public bus? 5 students. Number of students using school bus? 11. Number of students using cycle? 3. Number of students walking? 7. So this picture helps you understand at a glance the different modes of travel used by students. Based on this picture, answer the following questions. Which mode of travel is used by the most number of students? School bus. Which mode of travel is used by the least number of students? Cycle. So, a pictograph represents data through pictures of objects. It helps answer questions about data with just a quick glance. So, a pictograph represents data through pictures of objects. In the above pictograph, one unit or symbol is used to represent one student. There are also other pictographs where one unit or symbol stands for many people or objects. So, in the above example, one unit or one symbol, it represents one student. But in some cases, one unit or symbol stands for many people or objects. Nanda Kishore collected responses from the children of his middle school in Brescia regarding how often they slept at least 9 hours during the night. He prepared a pictograph from the data. So, Nanda Kishore, he collected responses from the children. See the responses. Always, sometimes, never. Children who always slept at least 9 hours at night. Children who sometimes slept at least 9 hours at night. Children who never slept at least 9 hours at night. So, the number of children is given using some triangles. And one triangle, it represents 10 children. Okay. Then we will answer the questions. What is the number of children who always slept at least 9 hours a night? Always. How many triangles are there? 5 triangles are there. See, one complete triangle, it represents 10 children. So, 5 complete triangles represent 5 into 10, 50. So, in the table, there are 5 pictures for always. Each picture represents 10 children. Therefore, 5 pictures indicate 5 into 10, 50 children. Next question. How many children sometimes slept at least 9 hours at night? Sometimes. So, you check this row. How many triangles are there? 2 full triangles and 1 half triangle. One triangle represents 10 children. So, 2 full triangles represent 20 children. Then half triangle represent 5 children. So, total 25 children sometimes slept at least 9 hours at night. See, there are 2 complete pictures. Triangle 2 into 10 equal to 20. And a half picture. So, half of 10 is 5. Therefore, the number of children who sleep at least 9 hours only sometimes is 20 plus 5, that is 25. Then, how many children always slept less than 9 hours each night? Explain how you got your answer. See, how many children always slept less than 9 hours each night? That is this row, never. How many triangles are there in that row? 1, 2, 3, 4 triangles are there. One triangle represents 10 children. So, 4 triangle represents 40. So, 40 children, they never sleep at least 9 hours in a night. See, there are 4 complete pictures for never. Hence, 4 into 10, 40 children never sleep at least 9 hours in a day. That is, they always sleep less than 9 hours. Drawing a pictograph. One day, Lakhanpal collected data on how many students were absent in each class. He collected data like this. Class 1, 3 students were absent, class 2, 5 students, like this. He collected data. Then he created a pictograph to present this data and decided to show one student as one symbol in the pictograph. That is, one symbol, it represents one student. Here see, he created a pictograph like this. See, for class 1, how many absentees are there? 3. Class 2, 5. In class 3, 4. Then class 4, 2. Then in class 5, no absentees. Then class 6, 1. Then in class 7, 5. Then in class 8, 7. So he created a pictograph like this. Meanwhile, his friends Jarina and Sangeeta collected data on how many students were present in each class. So, they collected data like this. In class 1, how many students were present? 30 students. Class 2, 35. Class 3, 20. Class 4, 25. Class 5, 30. Class 6, 25. Then class 7, 30. Class 8, 20. If they want to show their data through a pictograph, where they also use one symbol for each student, as Lekenpal did, what are the challenges they might face? Then it will consume more time and more space. So Jarina made a plan to address this. Since there were many students, she decided to use one symbol to represent 5 students. She figured that would save time and space too. See the pictograph, one symbol represents 5 students. So, in class 1, how many children are present? 30 children. So, how many symbols are used here in class 1? 1, 2, 3, 4, 5, 6. So, 6 symbols. 6 into 5, 30. Because one symbol represents 5 students. So, 6 into 5, 30. Then for class 2, how many symbols are there in the pictograph? 1, 2, 3, 4, 5, 6, 7. That is 7 into 5, 35 children were present. Likewise, she created the other classes also. Sangeeta decided to use one symbol to represent 10 students instead. Since she used one symbol to show 10 students, she had a problem in showing 25 students and 35 students in the pictograph. Then she realized she could use half symbol to show 5 students. So, she used one symbol to represent 10 students. So, in order to represent 25 students or 35 students, she could use half symbol. Half symbol represents 5 students. So, see, in class 4, how many students are present? 2 full pictures and 1 half picture. So, 25. See, here it is 25 students were present. What could be the problems faced in preparing such a pictograph if the total number of students present in a class is 33 or 27? It can be more challenging to prepare a pictograph when the amount of data is large or when the frequencies are not exact multiples of the scale or key. So, if the number of students are 33 or 27, it will be more challenging. Why? Because the frequencies are not exact multiples of the scale. Pictographs are a nice visual and suggestive way to represent data. They represent data through pictures of objects. So, pictographs are used to represent data and they represent data through pictures of objects. Then pictographs can help answer questions and make inferences about data with just a quick glance. In the example above about favorite games, favorite colors, most common modes of conveyance, number of students absent, etc. So, pictographs can help to answer questions and make inferences about data in a quick glance. By reading a pictograph, we can quickly understand the frequencies of different categories, for example, cricket, hockey, etc., and the comparisons of these frequencies. So, by reading a pictograph, we can easily understand the frequencies of different categories. For example, how many students like cricket, how many students like hockey. In a pictograph, the categories can be arranged horizontally or vertically. For each category, simple pictures and symbols are then drawn in the designated columns or rows according to the frequency of that category. Then what is a scale or key? A scale or key, for example, one symbol is to one student or one symbol is to 5 students, is added to show what each symbol or picture represents. Each symbol or picture can represent one unit or multiple units. See, in this case, one symbol represents one student. That is, one symbol represents one unit. Then here, one symbol represents 5 students. That is, one symbol represents multiple units. Figure it out. The following pictograph shows the number of books borrowed by students in a week from the library of middle school Ginori. See, a pictograph is given. It shows the number of books borrowed by students in a week. See, in the pictograph, days are given: Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. The number of books borrowed each day. Monday, how many books were borrowed? Tuesday, how many books borrowed? It's given. Then one symbol, it represents one book. So, how many books were borrowed on Monday? 5 books. Then, number of books borrowed on Tuesday? 4 books, because one symbol, it represents one book. Then Wednesday, 2 books. Then Thursday, no books were borrowed. Then Friday, 5 books. Then Saturday, 8 books. On which day were the minimum number of books borrowed? Thursday. On Thursday, no books were borrowed. Then what was the total number of books borrowed during the week? How do you find? Total number of books borrowed during the week? 5 plus 4 plus 2 plus 0 plus 5 plus 8. It is 24. Then on which day were the maximum number of books borrowed? What may be the possible reason? The maximum number of books were borrowed on Saturday, because the children can read more during the weekend, for weekend reading. Magan Bhai sells kites at Jamnagar. 6 shopkeepers from nearby villages come to purchase kites from him. The number of kites he sold to these shopkeepers are given below. So, shopkeepers' names are given and number of kites sold were also given. See, Chaman 250, Rani 300, Ruxana 100, Jasmeet 450, then Jeeta Lal 250, Poonam Ben 700. Prepare a pictograph using simple kite to represent 100 kites. So, one symbol, it represents 100 kites. So, here, Chaman, how many kites were sold to Chaman? 250. So, 2 full kites, it represent 2 complete kites, represent 100 into 2, that is 200. Then, 1 half kite, it represents 50. So, total 250. So, similarly, Rani 300. So, 3 full kites. Then, Ruxana 100. So, 1 kite. Then, Jasmeet 450. So, 4 full kites and 1 half kite. Then, Jeeta Lal 250. So, 2 full kites and 1 half kite. Poonam Ben 700. So, 7 kites, full kites. Answer the following questions. How many symbols represent the kites that Rani purchased? Rani purchased 300 kites. So, how many symbols are used to represent 300? 3 symbols. Then, who purchased the maximum number of kites? Poonamben, 700 kites. Who purchased more kites, Jasmeet or Chaman? Jasmeet. Ruxana says Poonamben purchased more than double the number of kites that Rani purchased. Is she correct? Why? Yes. Why? Poonamben purchased 700 kites. Rani purchased 300 kites. So double the number of kites Rani purchased is 300 into 2, that is 600. So 700 is more than 600. So Poonamben purchased 700 kites, which is more than double the number of kites that Rani purchased. Rani purchased 300 kites. Double 600. So 700 is more than 600. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see in the next video. Thank you.